Welcome students. So today I will discuss about topic from class 11 chapter, class 11, and that chapter is set theory. Set theory. Okay. So now what is set? A set is a well-defined collection of objects such that given an object it is possible to determine whether that the object belongs to the given collection or not. For example, suppose the collection of all students of Delhi University is a set, whereas the collection of all good books of mathematics is not a set. Since a mathematics book considered good by one person might be considered bad or average by other. Actually, set means collection. Collection of some element or data. Actually, in main thing we have to told that the set is a collection of some element or data. Is it clear to you? Now earlier I have told, suppose we take all the rivers of India. Okay. So this is a set. All the temples of India. This is a collection of set. This is a set. Similarly, in math, if we take, suppose we know the natural number. What is the natural number? That is 1, 2, 3, 4, 5, 6. These are the natural numbers. Okay. Now, if we take this together, we can say that it is a natural number set. A natural number set, and denote. Okay. And a set is denoted by any capital letter in alphabet. Okay, any capital letter of alphabet. So it is denoted by this capital letter. So we can write n equal to, we can write any set between to this bracket. Okay, second bracket. 1, 2, 3, 4, 5, 6. This is the unlimited collection. So this set is called the set of natural number. So is it okay? This is the set of natural number. So we can say that every number in that set, or every number that belongs to the given set, is called the element of the set. So here 1, 2, 3, 4 are the element of the set. Okay, set means natural number set. Similarly, if we take set of integers, set of whole number will get denoted by 1, 2, 3, 0, 1, 2, 3, 4, 5, 6. So these are called set of whole number. Next, and this is denoted by W. Okay, this is capital W. Next, if we take set of integer that is denoted by z minus 3 dot dot dot, first dot dot dot, that is minus 3 minus 2, next minus 1, next 0 1 2 3 dot dot dot, that is if we can write 0 is plus minus 1 plus minus 2 plus minus 3 plus minus 4 dot dot dot. So this is my set of integers, student. So this is set. Now the set is usually notation. As I earlier told you that the notation of set, a set is usually denoted by, it is usually denoted by A, B, C or any capital alphabetical letter. Okay, any capital alphabetical letter, that is the same. Next, come to the representation. Now the previous which I have written, the previous things, that is the previous representation is named as roster form of set. Representation of set, first is, there are two representations. First is roster form, second is tabular form. Roster form and tabular form. My first representation that I have already represented here, this is called, this is my roster form. Okay, this is my roster form of set. That is set of whole number, set of integer, this is set of natural number. This is in the form of roster form. Okay. Next, sorry, student, this is roster and tabular are same. Roster or tabular form. And the second one is this same. And the second one is set builder. Okay, set builder form. So my first form is roster or tabular form, that I have already done. This here you can understand that here from here. This is my roster form or tabular form, and this form is my set builder form. Okay. Next, roster form I have already show you. So next I have to show you the tabular form. Sorry, the set builder form. What is set builder? Set builder form, na? Suppose we have to write a set. We are writing a set like this. X, A is denoted by X, such that X is the prime number less than 10. Okay, is the prime number less than 10. So this is the form. We can take the values of x from this statement. This statement is given here. We can take the values of x from this statement. That is, if we can find the prime number less than 10. So the prime number, what are the prime number? The prime number less than 10 is 2, 3, 5 and 7. So these are the prime number. So we can write it as roster form like that. So the tabular form of this roster form is this, okay, and the roster form is this. Sorry, again I am mistaken. The set builder form of this set is this, and the roster form of this set builder form is this. Okay, so you are understanding that. Next, types of set. First is empty set or null set or void set. Okay, the set which doesn't contains any element. Set doesn't contains any element. That is called the empty set. It's called the empty set. And or void set or null set, generally denoted by this sign. It's called phi. Okay, it's called phi. Now let us take some example so that you can understand. Example: suppose the set of all real number whose square is -1. A statement is given here. The set of all real number whose square is -1. Now, is there any possibility that set of we can find, we can get any real number that's whose square is -1? It is not possible. So it is impossible. So we can't get any element referring this statement. We can't get any no element. So this is a void set or empty set, because we are not getting any single element with respect to this statement. Similarly, you can listen that suppose we can take the set of all rational number whose square is 2. Okay, the set of all those integers that are both even and both odd. So these types of statements not containing any single element. Okay, so this is empty set or void set. If we can find the set related to that element. Next, singleton set. Singleton set. A set having one element. It's having one element. A set having one element, that is called singleton set. For example, if we take this is one element, 0 is one element, so this is a singleton set. Okay, next, finite set and infinite set. Finite and infinite. Finite set and infinite set. Finite set and infinite set. It contains finite term, or element. Okay, infinite set, it contain infinite term or element. Okay, hope you understanding the definition. Next, equal set. If two set A and B equal set, two set A and B is said to be equal if every element of A is in every element of B. So that's are called equal set. Suppose we take A is equal to 1, 2, 3 and B is equal to 3, 2, 1. This element is matching with this element, this is matching with this, and this is matching with this. So this is called equal set. So we can say A equal to B, equal set. Okay, student. Next, equivalent set. To finite set, equivalent and equal not same. Okay, equivalent set to finite set has said to be equivalent if n of A equal to n of B, n of A equal to n of B, then A and B are equivalent. A and B are equivalent. Now, what is n of A and n of B? Suppose here in the previous example we take 1, 2, 3. A is equal to 1, 2, 3. So here my n of A is 3. That is the n of A means the total number of elements that present in that set. Okay, that is my n of A. Now n of B, here my n of B also 3. N of a set, that means the total number of elements present in that set. Okay, so this is called n of that set. Next, subset. What is subset? Subset, suppose now if A and B two sets, if every element of A is an element of B, every element of A, okay, if we take two set A and B, if every element of A capital A is an element of B, so we call that A is a subset of B, Okay. Now what is this statement's meaning here? What is this statement meaning here? Suppose we take A is equal to A, B, C, okay, and B is equal to B, A, C. So here if we take the elements, this present here A is present here, B is also present here, and C is also present here. So we can say that A is a subset of B here, and this is the notation by which we can represent notation of subset. Notation of subset. The notation of subset. Okay, now we can write here that A is a subset of B. Next, proper subset. Proper subset. What is proper subset? It's quite similar to the subset, but not like that. What is proper subset? If we take two sets A and B, if every element of A present in B, but if there at least one element in B that cannot present in A, then we can say that A is a proper subset of B. For example, suppose we take A is equal to A, B, C, and B is equal to A, B, C, D. Here every element present, A is present here, B is present here, C is present here, but D is not present in A. So that's why at least one element. Okay. Now if I take another set, C is capital C is equal to A, B, C, D, E, dot 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 dot. Okay. So we can also say that A is a subset of C, and A is a subset of, but here at least one element, D is not here. So we can say that A is a subset of B, and this is the notation of subset. And we can write that A is a subset of B. A is a subset of B. Clear? Next, some important point. What are those points? Some important points. What are those points? If A is a subset of B and A not equal to B, we write A is a subset of B or B is a subset of A is proper subset of B, or B is a proper subset of A. That I have already told you. Okay. Next, every set is a subset and a superset of itself. Now what is superset? This A is subset of B, so we can say that B is a superset of A. Understand that? Next, every set is a subset and a superset of itself. Okay, every set is a superset or subset itself. So you can write it here. Every set is a subset and a superset of itself. Is a subset and superset itself. Okay. Next, not a subset. Not a subset, we can write it here, or not a proper subset, we can write it like that. Not a subset, we can write it like that. Okay. Empty subset. Empty subset or empty set is a subset of every set. Empty set phi is the subset of every set. Phi is a subset of every set. Next, one important point, that is, if a set with n of A is equal to m, That is, if a set has n of a is equal to m, mean total number of element is equal to m, then the number of subset of a, number of subset is equal to 2 to the power m. Understand that? If a that is, let us take an example. Suppose we take a is equal to 1, 2, 3, and the subset of a is equal to 5 is the subset, 5 is the subset. Next 1, next comes 2, next 3, okay, next 1, 2, next 2, 3, next 3, 1, and lastly 1, 2, 3, that is equal to a itself. So now the total number of subset we got 1, 2, 3, 4, 5, 6, 7, 8, 8 subset. Na? Now here, look at here, if we take here my n of a is equal to 3, so 2 to the power 3 is equal to what? 8. So my 8 number of subset of a is coming here. Understand that? So this is the verification. Hope you are understanding that. Next, power set. Power set. Power set. A set of all subset of a given set A is called a power set of A, and it is denoted by P of A. Okay. Set of all subset. That is, suppose we take the previous example. That is, we take A is equal to 1, 2, 3, and the subset of A. These are the subset of A. 5. So suppose we take the previous example, that is, here my a is equal to 1, 2, 3, and the power set of a, P of a is equal to what comes? 5. Okay, 1, 2, 3, 1, 2, 2, 3, 3, 1, and a itself. Okay, so this is the power set. Now similarly, the power set of any element, power set of any set is containing what number of element? 2 to the power n element. Okay, power set of, so this is the power set of a. Next, clearly, suppose we have to find one interesting math. The math is P of, you have to find P of phi. Okay, we have to find that. So what we have to do? We have to find the power set of phi. Okay, the number of elements of what? How can you find this? We take P of phi is equal to this. Okay, power set of phi is equal to, next, power set of phi. This equal to what comes? Phi and this. Next, power set of phi. What comes? Phi. This. Next, this. Next, this. Okay, so the number of elements of power set of 5 is equal to 1 element, 2, 3 and 4. So the cardinal number, this is called the cardinal number. This is called the cardinal number of a set. Number. So here the cardinal number is, so the cardinal number of this is 4. Okay, so that's all for the first preliminary idea about sets. Now after that I will give you another video. On that video we have to show the operations of set. Okay, so till then keep watching, and if you like it, so please do subscribe my channel, please, it's my request. Okay, thank you.